Hi everyone, welcome back to another video. So we're still going through the K Stroud Engineering Mathematics book, and we're on the first review as part of the Trigonometry chapter. So let's get started. So in the review, they have 8 questions with the answers underneath. So we're just going to go through, answer all of these questions, and yeah, then we'll move on to the next part of the chapter. So question 1, convert the angle 164 degrees, 49 minutes and 13 seconds to decimal degree format. So what we'll do is we'll fill it out over here. So number 1, so it was 164 degrees, 49 minutes and 13 seconds. Decimal, right? Okay, so we've got 164, that stays the same. Then we're doing plus 49 over 60 plus 13 over 3,600, right? So this was in the first video, the second video. So 164 plus 49 divided by 60 plus 13 divided by 3,600, and that gives us 164.82. Cool. Okay. So we'll check our answers each time to make sure we're right. So that's question 1. And as you can see there, we got 164.82, and then they went to 4 decimal places, 8203. So we got that one right. All good. Okay. So convert the angle 87.375 to degrees, minutes, and seconds. Okay, so that's just the reverse, right? Let's go here, number 2. So we want to convert 87.375 to degrees, minutes, and seconds. Cool. So we take 87, that obviously just becomes the degrees. Then we take 0.375, we times that by 60, and that gives us 0.375 times 60, 22.5. That's our minutes there, 22. And then we got 0.5 times 60, which is obviously equal to 30. And so that gives us our seconds. So 30 seconds, right? So 87.375 is equal to 87 degrees, 22 minutes, and 30 seconds. Let's check our answer. 87 degrees, 22 minutes, and 30 seconds. Spot on. Go to number 3. Convert the following to radians to 2 decimal places. Okay. 73, 18.34, and 240. Okay, cool. So we're converting to radians, right? All right, and they wanted us to convert 73 degrees. B and C was 240 degrees. Let's check what B was. 18.34. Would have been impressive if I had remembered that. Okay, so when we're converting to radians, the thing to think about here is that 2 pi is equal to 360, right? So pi is equal to 180. So pi divided by 180 is equal to 1 degree. Okay? And 1 degree is equal to 0.0175 radians. So the more you do that, you'll start to just memorize this bit. But if you're unfamiliar with that, again, go back, watch the other videos again. It's always good to refresh yourself. Alright, so let's do 0.0175 times 73 degrees is equal to 1.2775 radians. We'll do the same again. 0.0175 times 18.34 gives us 0.32. Oh dear, I can't write today. 0.32095. Okay, now 240 will work it out a slightly different way. So since, let's write it, since 360 is equal to 2 pi, right? And 360 times 2 over 3. What would that be, right? That's 240, yeah? Okay. So therefore 240 is equal to 2 pi times 2 over 3. And obviously 2 pi is 2 pi over 1. So multiplying that across, 2 pi times 2 is 4 pi. That's such a dodgy looking pi. Alright, and then 1 times 3 is 3. So 4 pi over 3. So 240 degrees is equal to 4 pi over 3. If you want to do, we can obviously just simplify that here on the calculator. Let's do 4 pi divided by 3 is equal to 4.18879, so 8. So let's check our answer. So number 3 was number 3? Yeah, okay. So they rounded that one to 4.9. Yeah, 4 pi over 3. So 4.19 they did. But we got that one correct. No, B was 0.32090. 0.32095. Yeah, 0.32. And A was 1.2775. 1.27. Cool. Right, we got all of that correct. That's fine. Okay, so let's move on to number 4. Convert the following to degrees to 2 decimal places. Convert the following to degrees. Okay, so we've got. Alright, so we're converting to degrees. Okay. Alright, so we got A, which was 3.72 radians. What was B? Oh, this is the answers. I was confused. 3.72 radians, 7 pi over 6, and 11 pi over 12. Okay. So the one thing to remember is that 1 radian is equal to 180 divided by pi, right? So here we've got 3.72 over 1, right? Which is basically 3.72 times 180 over pi. Let's do that on our calculator. So let's do 3.72 times and then 180 over pi. That gives us 213.14. Let's check, all right? 213.20. Where did I go wrong there? Did I get the question right? 3.72. Ah, 3.721. I wonder if that makes a difference. Oh yeah, it does. There you go, guys. That's why you always read question. I tried to do it from memory, didn't I? So 3.721 radians equals 213.197, which is rounded to 213 point. The same again. So 7 pi divided by 6 times 180 over pi equals 180 over pi. Gives us 210 degrees. And then finally, same again. So I won't write it out, but same as that. Equals so 11 pi. Oh, I've cleared it. Let's go. I can go back, right? There you go. Oh no. Alright, let's do it. Redo it. 11 pi over 12. Okay, 11 pi over 12 times 180 over pi is 165. So we got 213.2, 210, and 165. If we're correct, 213.2, 210, and 165. Nice, correct, correct, and correct. Okay, so let's move on to number 5. Okay, so 5, they wanted us to find some values. So but find, I believe it's trig values, and there was 6 of them. We'll do it one by one. Okay. So we've got find the value of each of the following to 4 decimal places: sine 32, cos pi over 12, and tan 2 pi over 5. Okay, that's very simple. So sine 32 is obviously easy. 0.5514. Okay, so we carry on with B. 5B now. Cosine of pi over 12. The cosine of pi over 12. So the key point here was that I switched it to radians. So you can see up here, degrees. If you have it in degree mode, you might get 0.9999. Put it into radians, and you get 0.9659. Cool. Yep, and you can see that is correct. Oh, I've made a mistake on my sine 32. I had that in radian mode, so I need to change that back to degrees. if you look at the question here, third question, sine 32 degrees and then cosine pi over 12, no degree symbol, so that's obviously in radians. We have to bear that in mind. Okay, so let's change that. So we've got sine 32, this time in degree mode, 0.5299. So let's do C now. 5C, which is tan 2 pi over 5. Tan 2 pi over 5. And this is in radians, I assume. 2 pi over 5 in radians. 3.077. That's where you're gonna get caught out. You're gonna get caught out. There you go, 3.077. So they rounded up. Yep, that's correct. I should have rounded up as well. So you're just gonna get caught out when it comes to switching your calculator constantly back between degree and radian. Okay, next one. So secant 57.8. Secant 57.8. There's a little bit of a trick to do this on some calculators. Some calculators have the functions that work. Sometimes they just don't. So I find when I do, the secant is obviously cosine, right? Because the third letter is C. The cosine 57.8, right? And that's in degree mode, right? That's where you can get caught out again, switching it constantly back. And that's in degree mode. Again, that's where you can get caught out, switching it constantly backwards and forwards. So cosine 57.8, right? So then that equals so cos 57.8 equals 0.5328. We'll round it up to 9. Okay. Then now, equals then x minus 1 with the answer. And then so now you're just doing the inverse of cosine 57.8, right? So now you get 0.5329 to the power of minus 1 equals 1.8766. Let's check our answer. There you go, 1.87666. To illustrate this, so let's clear my calculator, and what I'll do is we'll do it again. So it's secant, right? 57.8. So you'd think that if you press shift and you press the cosine minus 1, right? Then put 57.8. He gives it to me like that. When you press details, like, yeah. So if you don't want to be dealing with that, you're better off doing it the method that I showed you. So if you get this kind of imaginary number stuff, then just do it the way that I did it. Do the cosine of the angle first, right? Get that number, put it to the power of minus 1, and then now you got the inverse. Okay, let's crack on. The cosecant of 13.33. Cosecant 13.33. Okay, so that is sine of 13.33. That gives us 0.2305, and then put that to the power of minus 1, and that gives us, so to the power of minus 1, 4.3373 when you round it out. Let's check again. 4.3373. Perfect again. Okay, so final one. The cotangent of 0.99 radians. Make sure we don't miss that bit out. So cotangent of F. We've got the cotangent of 0.99 radians. So obviously that's just the tangent of 0.99 radians. Put that into radian mode. Right. So that equals 1.5237. You round it up. Then you put that to the power of minus 1, and it gives us 0.6563. Take our answer. Nice. Cool. So got all of that right. That's all good. May need to make some more space. Oh no, I'll be fine. We'll go over here. Okay, so on to number 6 now. So we've got if this over here question. Given one side and the hypotenuse of a right angle triangle as 5.6 and 12.3 centimeters respectively, find the length of the other side. Okay, so in case you don't understand the question, you've got a triangle, you've got 12.3 I think it was, and 5.6. Could be either this one or this one, we don't know, but that's fine. And obviously it's just Pythagoras' theorem, a squared plus b squared equals c squared. Right, so then you've just got 5.6 squared. Now we don't know what b is, equals 12.3 squared. So 5.6 squared is 31.36 plus b squared, which is equal to 12.3 squared, 151.29, and then b squared is equal to 151.29 minus 31.36, right, which is 119.93. That's b squared, and then so you got the square root of 119.93, which is equal to 10.9513 if you round it out. Okay, let's check our answer. 10.9513 we're saying is this one, 10.9513. Okay, so they rounded it to 11 to one decimal place. 10.9513 to one decimal place, yep, is b is equal to 11 centimeters. Cool, okay, got that right. Let's move on to number 7. Show the triangle with sides 9 meters, 40 meters, and 41 meters is a right angled triangle. Okay, so we need to show that it's 9 meters, 40 meters, and 41 meters. So we showed this obviously by it agreeing with Pythagoras' theorem. If it agrees with Pythagoras' theorem, then it's a right angled triangle. If it doesn't agree, then it's not. So then again, a squared plus b squared equals c squared. You got 9 squared plus 40 squared equals 41 squared. Cool. So 9 squared is obviously 81, and then 40 squared is 1600, and then 41 squared 1681. So is that balanced? Yes, it is. Therefore yes, it is a right angled triangle. The answer, number 7. Yep, by satisfying Pythagoras' theorem. Cool. Okay, so on to number 8, the last one now, and we're done. That didn't take us too long. So a rod of length 7, okay, times the square root of 2 centimeters is inclined to the horizontal at an angle of pi over 4 radians. Okay, a rod of length, okay, got it. A rod of length 7 times the square root of 2 centimeters is inclined to the horizontal at an angle of pi over 4 radians. All right, a shadow is cast immediately below it from a lamp directly overhead it. Okay, what is the length of the shadow? What is the new length of the shadow? Okay, so it's 2 questions. Let's deal with the first part first. Let's go 8a. Cool. What they're saying is that you've got a rod that's cast in the air, right, and that produces a shadow, right? That's obviously basically making a triangle. So this rod is 7 times the square root of 2 in length, and we've got it's cast at an angle of pi over 4, right? And they want us to find out its shadow, which is x. So okay, so let's just go back to our basics. So what are we trying to find? We have, this is the opposite, right? they didn't ask us about the opposite. We don't care about the opposite, so the opposite ones are irrelevant really to us. We have the adjacent and the hypotenuse, so it's cosine, right? What we do is we do cosine pi over 4 is equal to, and then the adjacent over the hypotenuse. So what's the adjacent here? X, right? Or the length that we're trying to find out. And what's the hypotenuse? 7 times the square root of 2. Okay, so I'm gonna do this in a different color. One thing that should jump out to you is, do you remember this? Cosine pi over 4. If you've done the previous videos, this should jump out to you straight away. Pi over 4 is equal to what? 45 degrees, right? And that is also equal to 1 over the square root of 2. So in the book, on the K Stroud book, it's a page or two before this one. 2 pages before this one actually. So I would definitely advise you, if you're not okay with that, just go back and go over that again. But yeah, so 1 over the square root of 2 is this, pi over 4. So we can rewrite that whole thing by saying 1 over the square root of 2 is equal to, let's say the length L that we're trying to find over 7 times the square root of 2. So then that means that L is equal to 1 over the square root of 2 times 7 over the square root of 2. Sorry, 7 times the square root of 2. And then obviously all we have to do there is just put that over 1 and then multiply across. So we get L equals 7 times the square root of 2, all divided by the square root of 2. And then in terms of cancellations, these two cancel each other out, which means that L is equal to 7 meters, I believe it was. They didn't give us, but yeah, meters. Let's have a look. If L is the length of the shadow, then 1 over 7 times the square root of 2 is equal to cosine pi over 4, which is equal to 1 over the square root of 2. Yep, so L is equal to 7 centimeters. Okay. Yeah, so that we got that right. Let's do the next part of the question. B. I mean, the way they worded that, it made it sound like it was some sort of really super complex maths. Alright, so second part of the question. What is the new length of the shadow if the rod's inclination is changed to pi over 3? Nice. That's very good what the author's done there. If you spotted that, then you're probably at quite a high level of maths. Probably higher than mine. So the author's saying now, if the inclination was changed, I'm kind of giving it away with the way that I've drawn it. But so he's saying that if it changed to pi over 3, this angle, and this length remain the same, right? And we're still trying to find this one. Then you should know by now that this pi over 3 is another way of writing 60 degrees, right? Which means that this is 30 degrees, that's 90 degrees, so we're dealing with a half equilateral. So cosine pi over 3 is equal to x over 7 times the square root of 2. Okay, so again, from the previous video or the video before it, pi over 3 is 60 degrees. And what's that? The square root of 3 over 2, remember? So we can just place that into there, and that gives us the square root of 3 over 2 is equal to the length. I keep mixing between x and L, forgive me, but hopefully you know what I mean. Is equal to the length over 7 times the square root of 2. Right, so then make some space. Square root of 3 over 2 times times 7 times the square root of 2 over 1. Right, I'll just move that over there. Is equal to the length. Therefore, square root of 3 times 7 times the square root of 2. So you can just do square root of 3 times 7 times the square root of 2. You can leave that like that, right? Then you're all over 2 times 1, which is 2. And then we can just do that in our calculator. So let's go square root of 3. Oh dear. Okay, wait. I can. Okay. Times. You just want to make sure you're not putting this times underneath the square root. So times 7 times the square root of 2. And then that gives us L is equal to 8.5732, which we can round off to 8.6 centimeters. Cool. And yeah, there you go. 8.6. Bang on. Cool, guys. And I managed to fit it all onto one page, which is nice. So I enjoyed that. Hope you did too. If you did, leave a like. And what I'll do is I'll upload this to my Dropbox and leave a link for it in the description as well. So I'd advise you go through, do the exercise. I enjoyed it, so I'm sure you would as well. Cool, guys. Thanks for watching, and I'll see you in the next one. Peace.